Thank you for joining me today as I go through the implementation of webhooks within the GitLab source code. Recently, I've been interested in how to implement webhooks because it's a feature that we are trying to implement in one of our projects. So this is a screenshot from how you schedule a webhook if you have a GitLab account. You provide a callback URL. They use a secret token and they provide a custom HTTP header with the value of the secret token. That is essentially what you would use to authenticate the webhook on the receiver side. Additionally, you can specify which actions should generate a webhook that you're interested in. So these webhooks can be used to do custom integrations or also build a CI system, reporting system, things like that. The fact that GitLab is open source, so it's nice to see how they have implemented it. So I'm going to go through the code and let's find out if we can trace how when somebody merges a merge request in GitLab, how that merge request end up in the end triggering a webhook. So what I have here is the merge request controller. Within the merge request controller, there is a merge action. And the merge action calls this merge method, which after doing some validation and checking things, eventually it calls merge request dot merge async. So if we follow that, so we start from the controller, which calls the merge request model and called merge async. So essentially it takes care of things after merge. So if I go to the merge request model, so and if I find the merge async method, it calls the merge worker perform async. And then if I go to and then pass the ID. So if I go to merge worker, which then finds the user, finds the merge request and calls merge service dot execute. So if I go to merge service, so the worker is executed by Sidekick as a background worker, which calls a service. So if you go to merge service, in the execute method, we see that it does some work and then eventually it calls after merge. In the after merge, there is it calls execute on the post merge service. So and then now if you go to the post merge service, so this is all happening within a Sidekick worker process. So post merge service has a method called execute hooks, and that method is defined in the base service. So if you go to base service, inside there you will see a method called execute hooks, which calls merge request dot project dot execute hooks. So project has a method called execute hooks. So let's go to project. So if you see projects, you will see that the project model has many relationship with hooks with the class name of project hook. But we are looking for the method called execute hooks. So because each project can have many hooks, of those hooks, it tries to find out which ones to execute. So for example, for the merge, it's going to find out the merge hook. As we saw in this screenshot, there could be multiple hooks. So it goes back to the object that triggered the hook. and find all the active hooks, and then calls hook.execute async execute. So now if you go to hook, also all hooks are inherited from webhook, but in the project case it's called a project hook, which inherits from webhook again, and it has a method called async execute, which then calls webhook service and async execute. So I imagine this is where the webhook is sent. So let's look at webhook service. And then inside webhook service, if you see the execute async method, async execute method, it triggers another worker. So it's going back to Sidekick for running another worker for delivering the webhook. So if you go to webhook worker, then there we see that webhook worker goes to webhook service. So webhook service itself calls the webhook worker, and webhook worker calls the webhook service dot execute. So we are going a bit of a cycle there. So if you go to webhook service again, so eventually it calls the execute method, which makes a, if you see it, makes a request. It's a post request. So now we are going back to, this makes a HTTP post request, of course with the headers, and add some configuration for SSL verification, custom headers, things like that. Uses a basic auth as well, and if the provided URL has a username and password encoded, then it will also provide the basic auth, which is nice. That means that in this URL, you could actually provide a user colon password, that syntax, and GitLab will convert that into a basic auth header. And then it also creates a webhook log. So this is how GitLab eventually takes, when a merge request is merged, again, let's follow this. It calls the merge async. So basically starts a whole bunch of asynchronous processing after the merge, and then which calls the merge worker, which is a background process running in Sidekick, and then the worker calls the merge service, which calls the post merge service. I thought both of those are happening post merge anyway. And then the post merge service calls execute hooks, which is defined on the base service, and then goes to the project model and calls execute hooks. Project model then finds out which hooks to execute based on the type of the event, and calls async execute, which then goes to webhook service async execute, which then goes to webhook worker, which then comes back to webhook service execute. So I definitely found that tracing the source, which is the controller, and finding the point where the webhook is sent, there are quite a few hops to go through. It's not uncommon for Ruby on Rails apps that use a service pattern, but it's not, let's say, that my personal favorite, because it does get quite windy as we try to go from the business models into all these services, and the kind of the relationships are somewhat not obvious to me. But now if you go to the webhook model, we can see like how the model looks like, how it's modeled essentially. So inside webhook, the base class is called webhook, and each webhook has a token, which is the secret token we saw here. A URL, of course, has many logs, because you can be sending this many webhooks for the same URL. It does some validation, and Again, these execute methods, now I'm basically lost trace of which execute I'm looking at because there's just a series of execute methods everywhere. But it's fairly straightforward. We remember that the project class was using project hook, so this is the hook actually gets used. It's basically saying what are the types of hooks that are supported, and you can almost map these hooks one-on-one with these hooks on the UI configuration, and that's about it. So this is how it's modeled. Wanted to show the security side of things, but today's episode is getting a little bit too big. So I'm going to cut it short here and focus on the security of sending webhooks as per the GitLab source code for another episode. In the summary, I would say that while each of these methods were easy to understand, going from the source of a merge request being merged to the point when a webhook is sent, I found the path to be fairly long, and it didn't feel a very straightforward path. Could be a result of the service objects that are introduced within GitLab. But otherwise, I didn't have problem understanding how this thing works. So thank you for your time on this episode. I hope to see you again at a later episode. Bye.